All right, so thank you all again for waking up and giving me someone to kind of talk to. The first part of today's lesson is going to feel like a little bit of review. If you are referencing your textbook at all, it is the next section in chapter 10. So we introduced the basics of sequences on Monday. The first part of this is going to feel like a little bit of review. It's going to show you probably a variation on how to go about solving some of the questions that you're going to see in the no reassignment if you've been working on that. And then you're also going to see some new stuff today, and I worked on that again till late last night, and I will tell you a lot of what this section feels like. I'm certain that you could even come up with some real life situations where you'll see where all of this could come into play. I personally looked at it as I can now get questions right on those standardized tests. So for those of you who still need to take, I think it's the ASVAB or whatever it is that you have to do the CCP classes, or even ACT or SAT, however they're going to be giving those now in the future or in the near future. A lot of these questions you see on those tests, and when I was finished with looking at all of them, I kind of felt that those are the questions now that would be the easy questions when you get to those stressful standardized tests. So just kind of giving you an outlook as to what today's lesson is, kind of has that feel to it. So as you are either listening or copying as we go, the arithmetic sequences, that's what we worked on Monday, where it was just this list of numbers and we were looking for the pattern. Series, specifically, and I find this interesting, means when you add them all up. So a sequence, just a list of numbers. A series is when you're going to add them all up. So, for instance, it says, if you're given some terms of an arithmetic sequence, you can write the equation for the nth term. So in some cases, we don't know where we want to stop. However, we can write the equation to figure out what that last term, n, is going to be. Now, we did something like this already on Monday. So the example is we're going to write an equation for the nth term of this arithmetic sequence. So we have 5, negative 13, and negative 31. Now off to the side here, you're going to see I already have the steps written up as I was kind of starting my own notes last night just to know what to talk about. I realized, excuse me, they were all pretty neat. So I thought, why not just kind of use what I have, and then we'll go from there. So the first thing that we want to do is we want to find our common difference. So that's what you see over here. And all of this was just me trying to find our common difference. And however you choose to do that, if you see it, that's fine. So most of you probably just looking at this already knew the common difference was negative 18. If not, you can do that second term minus the previous, next term minus the previous, and find what that common difference is. The second step, and you're going to find this gets repeated a lot in the lesson today, plug it into the formula. All of our formulas, if you have all the variables but one, you can solve for that missing variable. So it really doesn't matter what we're trying to find. This formula, as long as it's an arithmetic sequence or has a common difference, not that common ratio that we talked about with the geometric sequence, this formula is going to come into play the whole time today. So we plug everything into that formula. The idea here is that we're trying to figure out an equation for that nth term. So you're going to have a variable left in our problem. We distribute and we solve. So depending upon what we have, if we know what the nth term is, so let's say we want a sequence that has 20 terms, We're going to plug 20 in here, and we can figure out what that last term is. If we have a sequence that has only 10 terms, we're going to plug 10 in for n, and now we can figure out what that last one is. So this is just our equation. Notice again, that's what I have here. It's an equation that's going to describe our arithmetic sequence. So our first was the common difference, and the second is plug it into the formula. So I have another example. I'm not going to go through and put all of our notes, but we are going to solve it. And we have write an equation for the nth term of this arithmetic sequence. Now I'm going to approach this, pardon me, the same way you probably would if you were doing your homework assignment. And we're just going to kind of eyeball what's going on here. And we can see from 12 to 3, we added a -9. And from 3 to -6, we added a -9. So right away, we know our common difference is -9. So we're going to plug all of that into our formula. That's the next step. A sub n equals a sub 1 plus d times n minus 1. And again, just me doing these, again, pretty much for the first time in many, many, many years, we're talking probably 16, 18 years, I've written this formula down probably in the last 5 days. It feels like 100 times, so it's already memorized, and I already remember what it's for, so continue to do so. And we can see that our first term is 12. We have our common difference, which is that -9. And when we distribute, we end up simplifying this to a sub n equals -9n plus 21. And again, that's where we're stopping. We want the equation. That way, if we're told then, and see, that's what we have to keep in mind, that maybe this isn't the last part of the question. Maybe this is just a part of the question that we need. And then maybe the question again is, what's the 130th term? So now we plug in 130, and we'd be able to figure out what n is, what that last a sub n is. So that's our equations. Now the next part is pretty much what we looked at a little bit on Monday. So when you're asked to complete an arithmetic sequence, we had a couple examples that I gave us on Monday, and we used our common difference to kind of help fill in the blank, and we talked about how many steps in between we were missing, what that common difference was in between, to know how many times do I have to multiply that together. This gap, these terms, are referred to as the arithmetic means between these two. Now, last year we briefly talked on an arithmetic mean, and that was with our two numbers. Well, we don't have just two numbers where we're trying to find the one in between. We're trying to find the individual 1, 2, 3, but they all have that same common difference. So we did show this on Monday. I'm going to show you a little bit of a different way to approach it. Might make more sense for some of us. If you've already had Monday's way mastered, not a big deal. This is pretty much the same. So the example that I have was find the arithmetic means. This time, all I'm really looking at is that we understand the vocabulary. Okay? We want to find the arithmetic means in the sequence, and we have -8, we have 4 spaces, and we have 22. The idea is that we have moved 5 times to get to 22. Now, if you are referencing the book at all, what you're going to find is that they're going to go through this reasoning as to where that 5 times comes from. Well, it's this idea that in this set of numbers that we have 1, 2, 3, 4, 5, 6. N minus 1, 6 minus 1 is 5. Again, to get from -8 to 22 was 5 steps. However, if you want to show how you got that instead of just counting, that n minus 1 is truly where that 5 comes from. And again, we plug it into our formula. So when we plug it into our formula, we have our first term, we have our nth term, so 22 equals -8 plus, we don't know what that common difference is, and we plug that in. And that's where we have. So if you remember on Monday, we did write this down. First term, last term, how many spaces times the common difference. And when we solve, you get your common difference of 6. So it's the same problem that we worked on Monday, just probably with more explanations. So now when you fill it in, you can add 6, add 6, add 6, so on. So when we write our answer, just know that it could be, what are the arithmetic means? You would say the arithmetic means are -2, 4, 10, and 16. And that's just a subtle reminder, not so subtle, that this is what we did on Monday. So some of you probably already did those questions in NORI. That's just another way to look at it. Okay. I keep watching the side here in the chat. If there are any questions, please type them in. I know that because you're watching stuff that I've already written, just remember, if for some reason you fall behind, you can, and I wouldn't even be able to tell you if you can pause something that's live and then move forward, but just know that you can rewatch and pause if for some reason I am going much faster because it's already written out. All right, so I do have an example. I couldn't remember. So this one, it's just presented a little bit differently. Instead of showing all those nice boxes in blanks in between, we do have find the 5 arithmetic means between -18 and 36. So pretty much it's like you are creating your own fill in the blanks. So we're going to start this problem the same way we did with our formula. So our a sub n equals a sub 1 plus d times n minus 1. And for right now, we know that if we were going to get from -18 to 36, this is actually 7 spots. So that's why we would have 1, 2, 3, 4, 5, 6, 7. Or you could say there's 6 moves, however you want to plug that in. So here, we know 36 is our nth term. Our first term is -18. We are trying to find our common difference so that we can get this pattern. And again, we have our 7 places minus 1. and we find that our common difference is 9. So every time we go to plug a value in, we're going to add 9 because that's a positive 9. So for each one here, plus 9, plus 9, plus 9. That's how we would have gotten to 36. So our answer, negative 9, 0, 9, 18, 27. So again, if we needed to, the 5 arithmetic means between are those numbers. So that's the part that's review from Monday. What's new is this. And it's a series. Now, our series is when we add everything up. So, very quickly, if I would say up here in the arithmetic series, I'd take negative 18 plus negative 9 plus 0 plus 9 plus 18 plus 27 plus 36. So, on Monday, we referred to a pyramid where in the first, at the top of the pyramid, there was 1. And then the next level, there was 3. And then the next level, there was 5. And the next level, there was 7. And so on and so on. And if it was a matter of knowing how many people I would need to fill a pyramid with 30 levels, I'd have to know how to add all those up. Well, again, drawing out a diagram and then counting or adding everything can get a little cumbersome, especially when you're talking about 30 different levels or 20-some different rows. So what we're looking at is this formula that we could use. So when we're trying to find the sum of however much our sequence has, it's actually referred to as a partial sum. Because again, in some cases, we have an infinite sequence. So that's why sometimes it's referred to as a partial sum. So we still have a sub 1, we're still going to have a sub n, and we're still going to have n. And sometimes we've got to solve for those first. That formula that we've been using is going to come back. When we have all of our information, we're going to be able to use this formula. Now, if you reference your textbook at all, there are 2 formulas. The other formula is much, much more extensive. Lots of grouping symbols and all kinds of stuff. This one, to me, seemed the most straightforward, and very quickly I was able to memorize it. So at times we're going to have to do a little bit of work, but this formula again seems to now be coming up more and more. And then we can actually find the sum. So just a really quick example where we would need to find the sum of all of those. Problem is, I don't know how big that set is. I don't know how many total terms there are. So the first thing I'm going to have to do is I have to find n, because if I don't have n, I can't use this sum formula. So first thing I do is I solve for n. Now I can see that my first term is a sub 1. I can see my last term, a sub n, and just by looking at the common difference, I can, without having to do too much work, recognize that it's 7. So I plug it in my formula. I have a sub 1, which was 12. I have the nth term, which in this case is 180. Again, I don't know what place that holds, that n position. I just know that it happens to have the value, the a sub n value of 180. And I solve for n, distribute the 7, and I get 25. So now that I know what n is, I can plug it into this formula. 25 times whatever the first term plus the last term divided by 2 is. And we end up knowing that that entire list of numbers is 2,400. So again, let's just say I needed to figure out how to, I don't know, display, I don't know why, pop cases just came to mind at a grocery store, maybe because it's always somebody's spilling them or something when they're running around a grocery store. That could be a way to figure out how many would go into that consistent series, that consistent sequence. So first found n, then was able to plug that in. So let's take a look at our next example. Same question. Find the sum of that arithmetic series. So again, we have our first term, we have our last term. We don't know how many are in this term, so we have to solve for n. So the first thing we're going to do is use our formula. And we have our 100 equals 2 plus, I'm going to assume that we can all see that our common difference is 2. And we end up with 100 equals 2 plus 2n minus 2. Or 100 equals 2n, because those are going to cancel. And we find out n is 50. So then we can look at what our series formula is. S sub n equals n times a sub 1 plus a sub n divided by 2. We now know there's a total of 50 numbers in this sequence. And first one was 2, last one was 100. And we end up with 50 times 51. So the 50 numbers in this sequence are going to add up to 2,550. Same question, just a different set of directions. So we're going to find the sum of the arithmetic series. Again, series meaning add them up. And now we have n, a sub n, and d. So the difference here is if I wanted to find the sum, I know that my sum formula needs n, a sub 1, and a sub n. I have n, I have a sub n, I don't have a sub 1. So, of course, I wrote this way too close to the next example. I'm going to plug it into my formula. A sub n equals a sub 1 plus d times n minus 1. And again, I'm using that formula because it's arithmetic to solve for the missing piece, which is a sub 1. So 240 and I'm going to cut to the chase and do 15 right away. So we have 240 equals a sub 1 plus 120. So we just found out a sub 1 is 120. Now I have enough to plug in here. So 16 times 120 plus 240 divided by 2 is 16 times 360. divided by 2. And we find out that the sum of that entire list, 2,880. Now, one of the consistencies, again, I'm going to just keep reiterating, is you're always going to see these two formulas now. So, almost done. I'm just trying to give you as many examples as I can, just on a variety of ways that they're going to ask you the same question, and it's going to be the same two formulas. So, find the first 3 terms in this arithmetic series, in which the first term is 7, the last term is 79, and now the sum is 430. Well, we need to again use our formula because it says series. Notice I'm using my context clues. Series. So I'm going to use this formula. But to complete the sequence, I've got to know the common difference. So use your formulas. So what we find out is if I use this guy, because I have enough, I have a sub 1, a sub n, and I know the other variable. So when I plug all that in, I'm able to find what n is. So now that I have n, I can plug it into this formula to find that common difference. So I used this formula with the values that were given to solve for n. Now that I know what n is, I can plug everything into this formula because the only variable left is the common difference. And I find the common difference of this series that I have no idea at the beginning how many there are or what the pattern is. I now know that I'm going to add 8 to every one of them. So if our common difference is 8, the first one was 7, so the second one is 7 plus 8, which is 15. The third one is 15 plus 8, which is 23. And if I was asked to keep going, the fourth one would be 23 plus 8, which is 31, etc. The first 3 terms are 7, 15, and 23. And of course, you could even be asked, what's the sum of the first 3 terms? Well, add them together. But the idea is, this time we started with our sum formula, used our sequence formula to then just list specifically the missing pieces. But these two formulas come up again and again. All right, let's take a look at what would be our last example. Same question. Find the first 3 terms of that arithmetic sequence. The minute I see S sub n, I'm going to go ahead and use that formula. And we're going to go ahead and plug in 120. 8 times a sub 1 plus 36 divided by 2. Now, please keep in mind that 2's in the denominator, so my 8 and my 2 are going to be able to reduce. And do that first, that way you don't have to worry about all your fractions. And now we have 4 times a sub 1 plus 36. Makes it a heck of a lot easier. Distribute. Subtract. And we end up with our first term of this sequence is going to be -6. So again, just using the formula to figure out how this list of numbers is going to start. And this list of numbers, our sequence, is going to start with a -6. Then I use my sequence formula to figure out what the pattern is, what that common difference is, that D. And we're going to plug our numbers in again. 36 equals, and now we know that -6 is where we start. And when we solve, we find out that D is 6. So if we want the first 3 terms, our A sub 1 we already knew was -6. A sub 2 was going to be our -6 plus that common difference, which was 6. So now we know it's 0. Our A sub 3 is 0 plus 6, so that gives us 6. And we could go on and on and on if they would have asked for the first 5 terms. So when we write our answer, the first 3 terms are -6, 0, and 6. We're done. I do want to show you one last thing. You can go ahead and if you want, look at it in your textbook. It is just another way to look at how we write sum. And many of you, SUM, many of you have probably already seen the symbol for sum. You see it a lot more, especially in statistics. But I did put this in here. It is at the very end of the section in your textbook. Honestly, you don't see it a whole bunch just yet, but I didn't want to just leave it out. It's this crazy looking E. It's called sigma. For those of you that have older siblings that are in a fraternity or sorority, you'll probably see that Greek letter more and more. The bottom tells us the first value of whatever our sequence or series is. And it's series specifically because we're adding, but we know that a series comes from this sequence of numbers that we're going to add together. The top is always our last value. So if we wanted to talk about a series like this, where we're going to start with our first term, whatever that value is, it's going to be our first A sub 1. This is our A sub n. This formula, that AF of k, is going to be the formula that gets us the actual values in our sequence. So first term, A sub 1. Last term, A sub 10. And here's the formula that's going to actually give us the value in each of those places. So I plug in 1 because it's the first value. I work that out, I get a 4. I plug in 2. I work that out, I get 7. Plug in 3, I get 10. Instead of writing out every single one of these, I can now do that space, put in that last value, and get 31. Now here's that sequence, 4, 7, 10, ... 31. And now I'm at all of these formulas again to know what to do. Now, you actually know how many values are in here. You know what your n is. Because if you have a starting point with the first value, an ending place with the last value, the common difference is how many positions there are. Well, some might say, okay, take n minus 1. 10 minus 1 would be 9. But there's actually 10 numbers in this sequence because you got to count the first one all the way through the last one. So there's actually +1, so 10 total numbers in that sequence. So by looking at this, you can already know what n is. That's what that top value is. So they're giving it to you, but that's also why it shows up that way, because there's that many in the series. But then you're right back to what we were doing in words. This just kind of cuts back on all those words. So you have your no reassignment. I will be adding a written assignment. It is just 13 short questions. In fact, every one of the examples that I did today gets you through those 13 questions. Friday, we will use as a if needed day. I'll check my emails, see how many questions I get, and check Google Classroom to know if we will be meeting. So until then, ladies and gentlemen, have a great day. Miss you all tremendously. Getting real bored. So see you all then.